So yesterday we started with introduction to two different types of supports. Okay, two different types of support. One is pin support and roller support. Okay, the support in the classification is the reaction. Like the force in support opposite support define. For example, pin support. The vertical force and horizontal force react opposite. That they can provide a reaction against vertical load and horizontal force. Okay, so it is represented by like this pin support, triangle. So this we are seeing. Pin support. Okay, then second type of support is roller. So this one, these are roller supports. So rollers are basically vertical force. It will take horizontal force roll just move reaction it will freely allow the horizontal motion, but vertical motion it will prevent. Okay, so it is generally denoted like this triangle roller ground. Okay, so this is a roller. So roller is capable of giving only one reaction. So we have seen some practical examples how they have built. One particular case is inclined item. Inclined pin support or something like this. Okay, so some angle it is given. So that is also possible. So these kind of things we have seen. Then we start with simple problem. Single load on reactions in the value. What is the resistance force or resistive force offered by the support? Support etra force ആണ് തിരിച്ച് സ്ട്രക്ചറിലോട്ട് കൊടുക്കുന്നത് എന്നുള്ളത് നമ്മൾ കാണുന്നുണ്ട്. Okay, so that is the reactions. Reactions value. So simply support number, we expect 3 reactions because this can give 2 reactions and this can give 1 reaction. So how do you find the value of the reactions? Right. So we use simple equilibrium to find the value of the reactions. Simple equilibrium, what is observation? Observation is this, that this body is not moving in any way. That means it is not translating in x direction. It is not translating in y direction. It is not rotating about any z axis. Okay, horizontal vertical rotating. Horizontal direction forces balance. So that means sum of the all forces in x direction. Sum of the all components of forces in x direction should be equal to 0. X direction is move. If a body is acted upon an unbalanced force, it will move, it will accelerate. Newton's law. Okay, so that's what we use. Vertical equilibrium. Some of the vertical components, vertical direction of all forces will take sum 0. Forces components of the force in vertical direction. So summation of F equal to 0. Then moment equal to 0. This plane either point about moment at 0. Okay, equilibrium. So all forces are point, any point you can take, any point, doesn't matter. Moment at 0. Moment is 0, it is supposed to rotate. The body rotate. So that is not happening. Okay, it is in equilibrium. So that is a case. Second, we have seen a problem in which the force is given at an angle. The angle over, we have seen what is the different forces coming. We use the equilibrium. Okay, so we have seen a simple problem like this. Assignment. So yesterday's assignment, there were a few confusion about checking. So initially, I think I have shifted vertical in A, vertical in B, and I want to shift it. So I think now it is correct. So assignment you have to complete this regular assignments only mark. There was one problems. It is easy for you to study for the end. Okay. Now I said we will take up a little more complicated force. We will add the number of force in the end number puta. Okay, so this is the force that we were trying to solve. So this is a bridge. Let's say it's a bridge. A car is going on. Car and the weight 20 kg. 2 tons on 2,000 kilo. Car and mass. Like 20 kg car and weight. Okay. It is equally distributed to 2 wheels. So 4 wheels are the car. So we will simple 2-dimensional. So we wheel constraint. So 10 km equal item distribute load. Okay. What is the reaction? This bridge is support reaction. Support is reaction. Force consider. reaction. Okay, one and the same thing. So we will start with that problem. So this is the problem. Problem is defined like this. We will simplify the one line diagram. So this is also known as one line diagram or single line diagram. Okay. Now we have to find HA, VA, VB. So we know that it is in equilibrium. Since the body is in equilibrium, we can always write summation of all the components of forces in x direction should be equal to 0. Summation of all the forces y component should be equal to 0. And moment about any point, about some point, should be equal to 0. Okay, this solve. So it is straightforward. What we do is we find the components of forces in x direction. Okay, so summation of forces in x direction. So what are the forces? So we can see that equal to 0. So we'll use this. Okay, so that means what is the forces? We will assume up as positive, narrow to positive. So we can start from the x direction. So it's x direction. So right as positive. Right as positive. So we'll start from the end. So there's a HA towards right. So HA is there, which is a positive force because it's towards right. No force, no horizontal force here, no horizontal force here, no horizontal force here because it's a roller support. Okay, so that means HA equal to 0. Now, this HA value is 0. Okay, so we can force vertical, horizontal force reaction. Okay, right. Next thing, next what we will take is let's say we will take summation of Fi equal to 0. Okay, so what is a summation of F in y direction equal to 0? Let's say up as positive. In the kind of force, we have a VA. VA is upward, so it's positive. Now afterwards, we have a 10 kilonewton downward. So 10 kilonewton, but it's downward, so it's negative. Then again we have a 10 kilonewton, it's also negative because it's downward. Then we have a VB under, which is positive. Okay, summation of all the forces should be equal to 0. So that means VA plus VB equal to 20. So this is something which we are going to use. Okay. Then last, we have to take any point and find the moment about that point. So preferably I will use this point or any point I can take. This point, a support point I can approve it. Direct force. Okay, so I'll take summation of moments about A. B equal to 0. B central point. It doesn't matter. Okay. So A, so let's say HA into A, HA into 0 plus VA times 0. HA 0 distance 0, so it doesn't matter. So VA into distance 0 because it is passing through K. Okay, again, what is the sign convention? Anti-clockwise positive. Okay, now 10 into 3, which is right rotating clockwise direction. So minus 10 times 3. Okay, now 10 times 3 plus 1, 4, 4.5. 10 plus 4.5. Either it is 10 into 4.5. It is also trying to rotate in clockwise direction. So minus. Okay. Then we have this force VB. VB into 3 plus 3, 6 plus 1, 7, 7.5. So VB into 7.5 anti-clockwise. So plus equal to 0. Right? Hello. So now this is gone. This is gone. We have minus 30 here. Okay. We have minus 45 here. Correct. Minus 30, minus 45 here. And we have plus 7.5 VB equal to 0. Okay, so 7.5 VB equal to, so 13, 75 minus 75 plus 75, which is 75. Okay. So VB equal to 10 kilometer. VB 10 kilometer. Now what happens? We'll put this VB in this equation. So substitute this. So from here, we know that VA plus VA plus VB equal to 20. We know the value of VB. So VA plus 10 equal to 20. So VA equal to 20 kilometers. Okay. So these are the three forces that we got. So 1, 2. So Fx is 0. So Fx actually is 0. So if I draw the free body diagram, we can draw the free body diagram. We have a 10, we have a 10, 10, 10. I have a vertical reaction 10 here. I have a reaction 10 here. I have a 0 reaction here. Okay, total relations. So this is VA, all kilonewtons. Okay. This is
Sir, VA 20 no?
VA 10 kilonewton.
Oh, 10, sorry. Thank you. 10 kilonewton. Okay. VB, VA, H. Right. Any multiple force I hope we can do. It will be 2 force and 4, 5, 6 force. So there is one more variation in this problem. Our variation what we will do now. So variation this is the variation. The variation in the so evaluate the reaction for the shown simply supported beam. Simply supported S bar S simply supported beam. Okay. That is a beam under simply supported. Okay, support okay, so this is practically possible. Either pin support and okay, you can see this. It is clear, I guess. At some angle is the pin. Pin in some angle. Okay, so that is very much possible. Support okay, how do you find reaction? Reaction. Okay, so the idea here is very simple. You think for a minute. Solve if you think a little bit, I hope you can solve this. How do you solve this? Any ideas? Anybody has any ideas? First, I will mark the reactions. Reactions mark it will be easy for you. Okay, so reactions. So we know that pin support offers 2 reactions, one horizontal and vertical, and roller support offers only 1 reaction. Okay, these 3 reactions I give a mark here. So that is the first job that I have to do. So what I will do is I'll try to mark the reactions. So let's say, so this pin has 2 reactions. So let's say I call this as A, I'll call this as B as usual. Okay, so let's say this is one reaction, VA, and this is another reaction, HA. And what is the nature of reaction here? Even the reaction. So if you imagine this support is supporting actually, it can freely move in this direction. Okay, roller, so it can move in this inclined plane. It can move freely like this. Okay, but vertical direction it cannot move. E plane perpendicular right it cannot move. So my reaction will be something like this, perpendicular to this plane. Okay, so this I'll call as VB. Okay, VB in the plane. Our plane is VB perpendicular to the plane. So this is 30 degree. Okay. Now, how do you solve this? So this the solution very simple. Complicated. Only thing is, inclined so this is the value of VB. Now, how do you find equilibrium? So it is in equilibrium. Okay, so this implies the summation of forces in x direction should be equal to 0. Summation of forces in y direction should be equal to 0. Moment about any point should be equal to 0. Okay, summation of moments about any point should be equal. So, അപ്പോൾ അതിന്റെ അർത്ഥം എന്താണ്? അതിന്റെ അർത്ഥം എന്ന് വെച്ച് കഴിഞ്ഞാൽ ഇത് it can have these three equations. If we solve these three equations, we are supposed to get these three values. Okay. Now that means this is x component, this is y component, this is z component. So what we will do, ഞാൻ ഇതിനെ simplify ചെയ്യാം. What we will do, we will just simplify this. Simplify in the sense, ഇതിന്റെ ഈ ഫോഴ്സിന്റെ ഡയറക്ഷൻ ഒക്കെ നമുക്ക് മാറ്റി നമ്മൾ all forces in horizontal and vertical components ആക്കി നമുക്ക് കൺവേർട്ട് ചെയ്യാൻ പോവാണ്. Okay. So what about this force? ഇതിന്റെ vertical component, horizontal component എന്താണ്? So we know how do you find this. So you have to travel down then left. So that means my one force will be, so I'll use some other color here. Okay, just give me a minute. Okay. So we'll have a vertical component like this. Okay, and we'll also have a horizontal component like this. Okay, so these are the two components that we can have. Right. So what is the value of this? This is 10. So if you complete this triangle, this is 10. This is theta. So this is 10 sine theta. This is 10 cos theta. Okay. So theta is 45 degrees. So 10 sine 45, 10 cos 45. 14 sine 45, cos 45 under 1 by root 1. So this is 10 upon root 2. This is also 10 upon root 2. Okay. So this is the two forces. I can replace this force by these two forces. So this that diagram. In either. What about this? Can I also find the horizontal and vertical force in this location? So basically, I will say so this is my support. Okay, I have a force like this, that is VP. I have to convert into two horizontal and vertical force. Now, what is the angle? Any angle. Angle it is easy for me. If 30 degree, 30 degree angle. Okay, so that is a question. So this is my plane. This is 30 degree. This is a perpendicular to the plane. Now, what I need is, if you observe clearly, I have a horizontal line here, a vertical line here, and I have a horizontal line here. Okay, so these two components are equivalent. This is my force. Then the force in the direction. E component, E component. So, this angle any angle can you tell me? Okay, so if you observe here, it is simple now. So if you know, this line and this line is parallel. This is horizontal line. So this 30 angle, this 30. Okay, this 30 angle, this 30 interior angles. And the line and E angle of interior opposite angles. And same area. So this is 30, this is 30. Now this total angle is 90. This total angle is 90. So this should be 60. Okay, so we are getting this as 60. Or we are actually getting this as 30. Because this is the 90 degree. So this is 60 degree, this can be also anyway. You can consider this 60 or you can consider 30. So I'll go with 60. Okay. 60 degree angle. So I have to find the components of the force. So this is 60, this is VB. Now these components can be written like this. One is a vertical component like this, that is VB sin 60. അപ്പോൾ ഇതിന് ഓപ്പോസിറ്റ് ഉള്ളത് sin 60 അല്ലേ? ഇതിന്റെ വാല്യൂ VB ആണെങ്കിൽ ഇത് sin 60. ഹൊറിസോണ്ടൽ ഫോഴ്സ് എന്നുള്ളത് VB cos 60. Okay. Now ഈ എല്ലാ ഫോഴ്സുകളും നമുക്ക് അവിടെ കൊണ്ട് എഴുതിയിട്ട് we can simplify that. Okay. So what I will do is I'll just simplify the structure. So let's take this. So I'll drop this off. I'll remove the supports and I'll replace that with forces. Okay. So there is a vertical force. There is also a horizontal force. Okay, the same line line of the multiplication. So this is 10 by root 2. This is 10 by root 2. Okay, and this force, this is VB sin 60. This is VB cos 60. Like VB sin 60, VB cos 60. Okay, so I can write there is a VB sin 60. There is a VB cos 60. There is a VA. There is a HA. These are the forces, components of all the forces. Okay, I hope this is clear. Confusion in the with the reaction, the reaction that two component force is two component. This force is component 20, so it doesn't matter. Okay, now I forgot to give distances, so let's take some random distances. 2 meters. So this is 3 meters. This is 2 meters. 2, 3, 2. Okay, 2 meters, 3 meters, 2 meters. Right. Okay, so I hope this is clear. I hope there is no doubt. Doubts on that you can unmute yourself and ask. Okay, now we can simply write those equations. So first equation, let's say it is summation of forces in x direction should be equal to 0. Now what is the forces in x direction? We have to assume right is positive. Upper right load or post force we have an HA here, so that is a plus. Okay, we have no other force. There are no other force. We have force here in left towards left. So that should be minus 10 by root 2. Then we have a left force VB cos 60 minus VB cos 60 equal to 0. Okay, so it will be helpful if you just find the values and write. So cos 60 it is nothing but half. Okay, so this is same as VB by 2. So that is simple to write. VB by 2. Okay. So root 3 by 2 will be cos 60. So this is equal to root 3 by 2 VB. So this is my first equation. Okay. Now second is summation of forces in y direction should be equal to 0, up positive. So here we answer we have two equations. We don't know how to solve this. Okay. Now we have Fy equal to 0, up positive. Here we have a VA. We have a VA upward. We have a minus 20 here. We have a minus 10 by root 2 here. Okay. We have a plus root 3 by 2 VB here. Okay. This should be equal to 0. So if you want to simplify this further, so this equation is same as HA minus 0.5 VB equal to 10 by root 2. So 10 by root 2 is nothing but 10 by root 2 I can write as 2 into 5 by root 2. So this will cancel. This will be root 2 remaining. So this is equal to 5 root 2. Okay. So this will be same as 5 root 2. 5 value 10 by root 2, 5 root 2 value. Okay, so here also we can simplify this. Simplify the VA plus root 3 by 2 VB equal to, so 10 plus 5 root 2. So 10 by root 2 is nothing but 5 root 2. Okay, അപ്പോൾ ഇത് പ്ലസ് റൈറ്റ് സൈഡിൽ പോകുമ്പോൾ പ്ലസ് ആവും, ഇതും പ്ലസ് ആവും. 10 plus 5 root 2. Okay, so we have one equation. We have the second equation here. Now we also want to find one more equation. So what I will do is I will find moment about b, because this root 3 root 2 onnu venda. I'll try to avoid those things. Let's see. So summation of moment about b equal to 0, anti-clockwise positive. About this point and now about b. Okay. So arbitrary, any point you can take. I am just taking this b point because otherwise root 3 is b point at root 3 by 2 into 0, bb by 2 into 0, that is 0 I mark. So I think there is an advantage here for me. So let me see. So anti-clockwise positive. So we will see from this force HA is passing through b. HA the line of action b. So HA is 0. HA is moment. HA into 0. Okay. VA into movement into 5 into 7. So VA into 7 is clockwise, so it's minus VA times 7. Okay, 10 times 5, 3 plus 2 5. 10 times 5 is anti-clockwise, so plus 10 times 5. Then 10 by root 2 times 2, it is also anti-clockwise, plus 10 by root 2 times 2. 10 by root 2 times 2, anti-clockwise, so it's positive. Okay, then 10 by this 10 by root 2 are 10 by root 2 line of action on b, so perpendicular distance will be 0. Okay, so plus 10 by root 2 times 0. These two forces 0 0 should be 0. Okay, so this is bb cos 60 into 0, bb sin 60 into 0, so that will be 0 0. So summation of all the moments should be equal to 0. Minus yeah.
Sir, 10 into 5 എന്ന് എഴുതിയിരിക്കുന്നുണ്ട്. അത് 20 അല്ലേ? അത് 10 ആക്കിയേ.
Right. 10 into 5. Okay, it is 20. Sorry. Thank you. 20 into 5. So this kind of mistakes when I am doing, I will do a lot of mistakes like this. I will just tell you. So 20 into 3 plus 2 5. Okay. So what do you will get? This is 0. So this is minus 7. Minus 7 VA. This is 50 plus 50. 2 so plus 100. 20 into 5. 2 5 is 10. 100. Okay. Plus this we can write as root 2. 10 root 2. Okay, root 2 into 2, root 2 and 2. Root 2 cancel like 10 root 2. Okay, plus 10 by root 2. So 10 by root 2 is same as 5 root 2. 5 root 2 equal to 0. So 10 plus we can say 15 root 2. Then what equal to 15 root 2. 100 plus 15. Okay. Now if I take this VA out that side, if I take the VA, so we are getting a value of VA. So that is good for us. So if you observe here, what do we get? Okay. I'll take VA to that side. Okay. I'll take this equation.
5 root 2 into 0 അല്ലേ?
ഏതാണ്? എവിടെയാണ്? ഇതാണ്.
Next.
ഇത്.
അത് 0 അല്ലേ?
Wait. 10 by root 2 is 0. Okay, fine. Okay. So this term is not there, right? This term is not there. Correct, right?
Yes.
Okay, thank you. Okay. Equal to 0. Okay. So now it is simple, slightly simple. Now if I take this to next. Okay, so this will take right side. So 7 VA equal to 100 plus 10. Okay, so VA equal to 100 plus 10 root 2 by 7. In the value, the value VA value. Just calculate this. Just calculating.
16.3 ആണോ സാറേ?
16. I think so. This is another equation which you have done. Okay. So what is the value of VA? 16.3. 16.30. Okay, 16.331 kilonewton. So that is VA value. Now we'll substitute this here. 1. Then what will you get? So let's say 16.31 plus root 3 by 2 VB will be equal to 10 plus 5 root 2. Okay. So root 3 by 2 VB equal to 10 plus 5 root 2 minus 16.31. So what is the value of VB? VB value 3. So VB equal to 2 by root 3 times 10 plus 5 root 2 minus 16.31. So I think it will be wise to move this to this side. So this way I am putting here. So how much is the value? എത്രയാണ്? എത്രയാണ് വാല്യൂ വരുന്നത്? കാൽക്കുലേറ്റ് ചെയ്യും.
സാർ
0.888 അല്ലേ?
ആ.
0.88. It must be correct. So VB value is 0.88. Okay. Now what about we'll substitute in here. In administration we'll substitute in HA equal. So HA minus 0.5 into 0.88 equal to 5. So what is the value of HA? HA value.
$7.511.
7.511. 7.511. 7.5. So we have all the forces. We just have to draw the diagram. So this is my diagram. So we have HA is 7.5. So let's say HA is there. HA is there. Will be here. So HA, what is the value of HA? 7.5. Okay, so what is the value of VB? 16.31. So this is VB. This is HA. Okay. Then we have two loads here. Okay. Then we have a reaction here also. That reaction is inclined. What is the value of reaction? Is 0.88. Okay. What is inclined S? What is the angle of inclination that is rotate? It is 30 degree, 60 degree. So this is 30 degree here. Okay. So this is V. Reaction. Okay. So this is how it works. Okay. Great. So let's see that. So let's check once more. Okay. So there is 20 here. There is 10. The reaction of the force on the number components. Force in a reaction is the number components, vertical and horizontal components. So it is easy for us. Easy at the vertical force and horizontal force. So this main key is inclined support in the number of force. Inclined support in the force. That's the vertical and horizontal. This is horizontal vertical. This is horizontal and vertical. That's the challenge. This angle, inclined angle, force in the angle VB cos 60, VB sin 60. So VB cos 60 and VB sin 60. Okay. So there is a horizontal VB cos 60, vertical VB sin 60. Okay, VB sin 60, VB cos 60. So we have force in right? Yeah. In session, summation of all vertical force in x directions is HA minus 10 by 2 minus VB by 2. 462 462. So what we are getting is we got an equation like this. HA minus 0.5 is 10 by 5. Okay. Then vertical force will come we got an equation like this. The notes moment about this point. Okay. So VA times 7 plus 20 into 5 plus 10 root 2, 10 by root 2 into 2. Okay. Okay. So then we got value is 7. Okay. Then another equation substitute. Okay. Plus 5 root 2. Then we got the value. Okay, fine. So I hope this is clear. So this can get further complicated. So how can this get further complicated? So this is something I think the syllabus is complicated case. So let's say we have a pin here. We have a roller. Okay. Sometimes. Okay, let's say even there is a small number like this. There is a number like this. Okay. Then there is a force here. So let's say this can be 10 kilometers. Okay. All distances. So this will be 2 meters. This will be another 2 meters. This will be 3 meters. Okay. So find the reactions. Find the reactions. So this is complicated question. Okay. Now this support inclined all those things can be happen. So what I will do is this problem we will see how to solve this. It is solved in many methods. Very complicated this entire system can be considered as one way. Okay. Another way of doing it is we can get rid of this. Get rid of this no rebo. So this is our member. Our member is that. Okay. 10, 2. So let's say this height is also given. I don't know why we should give this. Let's say this is also given 5 meters, 0.5 meters. Okay. So this is 0.5 meters. So this is my beam. Okay. So E force I can transfer to this point. So how do you transfer this load to this point? Okay. So there is a possibility. So this system and some other system in which the load is here. Okay. It is same. We'll get a force here. Vertical or horizontal movement. Now, this force. Okay. Force normal. So what we'll do? This one I'll record a video. I'll record a video on this problem, how to solve this, and I will share it with you. Okay. What is the explanation? Because I don't want to spend more time on this every supported beam. I want to start a friction type portion. So this I'll post 1 or 2 videos, 2 or 3 solutions as video. Okay, our video I will model share. Okay, right. But this is a question which was asked I think last semester exam, which problem was similar to this. Okay. Sorry for that. Now I think we can start with what is known as friction. Okay, friction. I'll just give you some introduction today. Okay. So friction force, it is basically we are dealing with friction between solid bodies. Solid bodies. Okay. So we have a surface, we have a body. Because of contact, there can be some friction here. Maybe this is 10th friction. So this friction is basically called as Coulomb's friction. Coulomb's friction. Okay. What is the other type of friction? So other type of friction is so what is the other type of friction? Where type friction is body under body oil okay. So there is a small layer of oil between fluid between these two processes. It's a different type of friction. Observe object smooth. So between the surface and the body, there is a small layer of oil. Okay. So oil the samayathu ee rendu object thamil mechanical contact alla, there is a layer of oil in between these two, and the oil will reduce the friction. Okay. So this you will study in your second year in fluid mechanics. Fluid mechanics is we are dealing with the Coulomb's friction. So this Coulomb's friction is not 100% properly understood phenomenon, but then what we know this is okay. It is caused due to roughness between substances between surfaces. Okay, and the force, the Coulomb friction force, is proportional to the normal force. അതായത് ഒരു ഒബ്ജക്റ്റ് ഉണ്ടെന്ന് കരുതുക, ഒബ്ജക്റ്റിന് ഒരു കോണ്ടാക്ട് ഉണ്ട്. അപ്പോൾ ഈ ഒബ്ജക്റ്റ് കോണ്ടാക്ട് ഉള്ളതുകൊണ്ട് this object will put some force on the surface will give an equal and opposite contact force. This is also known as normal force. Okay, this is the object's force by from the object, some F. So ഇത് ബാലൻസ് ആവാൻ കാരണം വെച്ചാൽ ഈ ഒബ്ജക്റ്റ് ഇപ്പം നമ്മൾ ടേബിളിൽ ഒരു I think I have given you this example a lot of times. നിങ്ങൾ ടേബിളിൽ ഒരു ബോക്സ് വെച്ചു, ഈ ബോക്സ് is putting some weight on the table. Okay, but then basically on the table നോക്കി കഴിഞ്ഞാൽ നിങ്ങൾക്ക് you can see that there is a weight or the other way of saying this is, if you take the boxes, there is a weight acting downward, gravity is pulling out. Where the force is, it will just go down. But we are observing that it is not going down. Box because there is a gravity acting like this. Okay, but my box is not moving. Many boxes are moving. And the gravity opposite force the table box in apply like this. So that is what is known as normal force. Okay, so this friction between these two bodies is proportional to the force which the bodies the surface is acting on the body. That is normal force in proportional. Okay, it is basically equal to mu times m, where mu is the coefficient of static friction. Static friction. Okay, mu times. So this also you might have studied in plus 2 coefficient of friction. Plus 1 static friction. So static friction, there is another friction also which is known as dynamic friction. Dynamic friction. Dynamic friction. So what you do is you table 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 force apply but then force there will be some point that it movie. Okay, then you will observe that push force force is a movie. Okay, push resistance resistance movie. So pushing when the body is at rest, there is some friction force, that is a static force. But when the body starts to move, there is another friction force, which is called the dynamic friction force. Okay, so generally static friction force is lesser than dynamic friction force. Okay, so that is another thing. So once the body starts to move, there is again mu times n in the opposite direction, but this is dynamic friction. So if I draw a plot, but let's say I have a body under. Body is in contact with some surface. Okay. I am applying a force here. There is a weight of the body up downward. So that means there is a friction force or normal force upward. There is a weight downward. I am slowly increasing the weight of the magnitude of the force. Keep force in the magnitude. Okay. So there will be a friction force in the opposite direction. The magnitude of friction force will be mu times n. Okay. Body mu time n body weight friction force. Weight body force okay. So when mu equal to f equal to mu n, f mu n value same the movie. Other friction will slowly be equal and opposite to f. So if I write like that over the time, so let's say you are increasing force. Force is increased with time. Okay, so we can observe that my friction force will also increase with time. Okay, then at some point it will just suddenly reduce and it will become constant. So if area it is static friction, then it will be dynamic friction. Okay, so all these concepts in the class we'll take some examples and explain, then it will be more clear. If you have idea if you're not understood anything, don't worry. Another class we will again take small problems and we will start explaining how this works. Okay, so friction is a comparatively bigger module for us. Maybe 2 or 3 classes we have to spend on friction to complete the module. Okay, so I think we can end our class today. If you have any doubts, you can ask.